Hi everybody. Hello. Welcome back to Learn with Earthquake Dude lesson number 8. The continuation of plate boundaries. It should be titled more of convection, but we still are talking about plate boundaries. Welcome back everybody. I hope you're excited cuz I know I am. Before we begin, make sure you guys drop a follow on my TikTok, Twitter, and Instagram. It would mean the world to me. So thank you. I'll give you 2 seconds. Go ahead. Go follow. All right. Welcome back. Yeah, let's get today's lesson going. We are going to talk about what causes the plate boundaries to move. It's a good topic. Good topic. So let's jump right back into it. So we will still be talking about plate tectonics. I want to start off with this map. It's such a beautiful, colorful map. But this map is showing you the main 16 large tectonic plates. There's the Pacific plate, the North American, South American, Antarctic, Nazca, Eurasian, Indo-Australian, Arabian, African, South American, which I think we said already. And then you see the little Juan de Fuca plate right there, and then the Cocos. You can see the San Andreas as well as highlighted. So again, the lithosphere is where all these plates are created. So every single plate you see here, that is part of the lithosphere gliding on top of the asthenosphere. Which, if you don't remember, go ahead and make sure you check out the other lessons because we're building on top of that stuff. Okay, so we know what causes earthquake. We know that because of the plates move, that creates fault slip, which ultimately creates earthquake and earthquake shaking. So what causes the plates to move? That's what we're gonna focus on today. And the answer is convection. Okay, so convection is when hot material expands, becomes less dense, and therefore rises. Cold material, on the other hand, contracts, becomes more dense, and it sinks. So, in a hot summer day, you guys ever notice that the second floor is always hotter than the first floor? That's because the properties of heat and density are the same. Heat rises because it's less dense. Another example is a pot of boiling water, right? When you boil some water for your cup of noodles or your ramen, right? Or your coffee or your tea, the water closest to the source of the heat, meaning towards the bottom of the pot, is going to start to heat up first. Then it expands, becomes less dense, and it starts to rise. As it's rising, it's going to push that colder water near the top of the pot back down, where it's going to be exposed to the heat and start heating up. Then that water heats up, becomes less dense, and begins to rise. And now you're creating these convection cells that are continuously moving. And that right there is what controls plate tectonic motion. So in the mantle, in the asthenosphere, we have these large convection cells that are constantly moving, right? And as these convection cells are moving, hot material is rising at these mid-ocean ridges or divergent plate boundaries, which is what we see because we see volcanoes, underwater volcanoes. And that material is being pushed down towards the cold subduction zone. So that's how we get these plates to continuously move. And that's it. Large convection cells cause the plates to start to move. So, but what is causing the material in the mantle to heat up? Or there's got to be an energy source, right? Because if it's starting to heat up, become less dense, and rise, there's got to be an energy source. So what is that energy source? Well, I'm glad you asked. The energy source actually comes from decay of radioactive elements in the Earth's core. So to answer that question, where does the heat that drives convection in the mantle come from? Mostly the decay of radioactive elements in the Earth's core. So there's also some heat left over from the formation of the Earth by the accretion of asteroids and meteorites. So you can see here's a picture of a big explosion when Earth first started to form. There's still there's still leftover heat in the core, and that's what's heating up the material in the mantle, which ultimately creates convection cells, which then you get the point here. So ultimately, what causes earthquakes? It starts with the decay of radioactive elements and the leftover heat from the earth, which creates heat. Okay? And then that heat starts to warm up the mantle and creates these mantle convection cells, which then causes the movement on tectonic plates, which then creates slip on a fault, which then creates the earthquake and the seismic waves that you feel when an earthquake occurs. And that is the cycle of life of how earthquakes are made. So theoretically speaking, if we ran out of source heat from the Earth's core, then it wouldn't heat up the mantle, right? Therefore, the mantle wouldn't create convection cells. Then the plates would stop moving, and there would be no more earthquakes. But could that really happen? Realistically, no. No. So we're always gonna have earthquakes, especially in areas near plate boundaries, which is why it's so important that if you live near a plate boundary, it is critical that you are earthquake ready, because these things are not gonna stop moving, and even though there's an earthquake, they're gonna continue to happen at plate boundary. So now that you know what actually causes earthquakes, we ask ourselves the next question. Click to add title. What controls when a fault slip? Ooh, now we're taking a different approach. But you're gonna have to wait on that one, because that brings us to the end of lesson 8. I hope you enjoyed that. I hope you learned something. Let me know what you learned in the comments. If you have any questions, any concerns, anything, drop a comment. Let me know how that went. Don't forget to drop a like, show some love to the video, and also subscribe for future videos. We got some good stuff coming up, continuous lessons, and I have a surprise for you guys here on YouTube very soon. Hopefully next week. Don't want to say too much. Again, thank you guys so much for watching. I will see you guys in the next one. Much love. Peace.